Thanks a lot for the introduction. So I'm not gonna spend more time, but just for us, it's a pleasure to present our first speaker for this workshop. That is Professor Rafia Inam. And just a brief introduction of her bio. She is currently a senior project manager at Ericsson Research in Trustworthy AI and adjunct professor at KTH in Sweden. And she has a broad experience in trustworthy AI, explainable AI, risk assessment and mitigation using AI methods, and safety for cyber-physical systems for telecom and collaborative robots. So please, Rafia, it's a pleasure for us.
Thank you so much for the nice introduction. Let me share. Please inform me when you see the slides. You see
Yeah,
my
we can
screen?
see it, but not in.
Yeah. And
Okay.
now?
Yeah, but it's not in. Okay. Right now, it's okay.
Okay. So you see it in the presentation mode now. Good. So just to tell you now, I can't see anyone. So you need to guide me if there are some questions or hand raised during the presentation. And of course, you can ask any question and interrupt me during the presentation as well. So hello everyone. Uh, Today I will be talking on trustworthy AI and then going a bit into the details of explainable AI for the telecom domain. And the time is short, 20 minutes. So I will like limit the presentation to a bit too high level. And as Alunos introduced me, I'm driving trustworthy AI within Ericsson and based in Kista, Sweden, the head office. And also I'm a adjunct professor at KTH and working on the same topic at the university as well. Yup. And then, as you know, like coming from the industry, basically, and from the telecom, Ericsson develops like networks, cellular networks, and so you will be like wondering what we are doing there. So the AI is paving its way more and more, not just into the other industry, but telecom is the same. This is, but then their question arises about the trust on the AI, especially when we use uh, black box models. Uh, and then we really want to do the right thing in the right way and to explain why the AI model arrived at the certain decision and how it arrived at the certain decision, to explain the behaviors of the model as well, so that we have the transparency and understandability of the model as well, alongside ensuring that yes, it is doing the right thing. And then the safety, privacy requirements are also there. AI should not harm anything or anyone around it, and both physically and ethically. So previously, like we were not having a lot of discussion about the ethical parts, but now that is also a big concern in the human minds. And other thing is that the regulations are moving quite fast to regulate the artificial intelligence and to make the AI more reliable and trustable. You might know that the AI Act was finalized in December, and I think it will be finally signed this month, or yeah, hopefully. And then we will have like around 2 years or 2.5 years when it will be practically implemented, and all the industries have to comply with that part. Uh, in addition to regulation, the standardization bodies are also providing their own standards to make the AI trustworthy. So it is like, if you use AI, then trustworthiness guarantees are like a must thing there. Then, and like all these the things which we attain from the trustworthy AI technology enable the trust. It helps us to adopt the AI in the not just in the telecom but in the society. It enables the customer trust and satisfaction. But for us, there is one other advantage as well, which we discovered while when we were working and implementing the technology in the telecom domain, that we were able to discover the new and unexpected behaviors as well using our models. And especially it was true when we started to move the AI models, ML models to from the simulated environments to the test beds and or from the test beds to the real network. Then trustworthy AI techniques helps us a lot there as well to understand why models are behaving unexpectedly or what's new there. So the question arises that what is trustworthy AI? In simple terms, if I say, then it means that AI should perform what it is intended to do, and it should not harm both physically or ethically. That is like the simple definition of the trustworthy AI. If we see the European Commission guidelines, the ethics or the upcoming AI Act, then it says that AI should be lawful, ethical, and technically safe and robust. So that is like the official definition according to Commission. But then, of course, there are other definitions as well from DARPA, from Stanford, and from other organizations. Uh, When it comes to the regulations, I already mentioned the EU AI Act, but it is not that the Europe is working on it. I think regulations are coming up like all around the world. We saw the National Security Commission for the AI in US, and then last year in 2022 October, they provided blueprint for AI Bills of Right, and then in May they moved forward, and then last year in October, US signed their executive order on safe, secure, trustworthy AI part. The US president signed that order. Canada also has their own regulations on the AI and Data Act. And then, of course, other bodies are also working on the regulation. So the field is moving fast, and we also need to move fast to keep the pace of the technology then. Um, at Ericsson, as I mentioned, that we develop networks, and our purpose or our long-term vision is that we should incorporate AI into the networks, and all these AI systems or AI techniques that we incorporate should be trustworthy, and they should be trustworthy by design. It should not be an ad hoc solution later. They should be incorporated in the telecom domain from the start by default. And by that, we mean that the telecom system should be safe, robust, reliable, explainable, and sustainable. And to do that, we do research. We also check state of the art methodologies on the trustworthy AI solutions, both for machine learning and reasoning techniques of the AI, and then we apply them on the telecom domain and at the all layers of the telecom network, basically. Yeah, so trustworthy is a big term. As I said on the last slide, they should be safe, robust, reliable, explainable. So what is actually included in the trustworthy AI, this big umbrella term? It simply means like that we need to meet 7 requirements, and these 7 requirements are coming from I took them from the European Commission guidelines. Ericsson complies to them. US has their own guidelines. UK has their own. Okay. Uh, but like these requirements are a lot overlapping from the regulatory aspect. I find like that European Commission guidelines are more detailed and comprehensive, so I'm presenting them there. The first is that humans should have like control all the time. The AI models should be explainable and transparent. They should be accountable, privacy preserving, non-discrimination. They should make the fair decisions. The data should be fair. The algorithms should be fair, and yeah, of course, safety requirements are there, and AI should work for the societal and environmental well-being. Yeah, this was a bit overall, a bit very brief intro of trustworthy AI. I drive explainable AI in technical detail when it comes to the technical details. So I will go a bit deep into the explainable AI part there. So we have used explainable AI methods to ensure transparency, basically, the transparency requirements, which is one of the main requirements of trustworthy AI. But we have seen that it is not just that explainable AI method not only provides transparency, but it also enables us to make sure that the AI is doing the right thing in the right way, and black box AI models are behaving correctly, and we can identify and explain the new behavior or unexplained behaviors of the models. So, explainable AI, as its name showed, it should provide some explainability. This explainability is provided at different levels and also for different types of users. Uh, For telecom, we usually separating them, the external users or the internal users. For external users, like we have operators, the explanations should be very high level. They should be in natural language form, for example. For internal users, which can be developers or testers or model monitors or network operation center engineers who are like maintaining the network 24/7. For them, the explanations can be in detailed as well, like the feature importance or the features or the detailed technical. And I will provide you an explanation on this particular thing also. In addition to that, we have seen that using the explainable AI, we can use them to identify the root causes, which will in turn enable the automation of the complete systems also. And of course, we can use explainability to meet human agency and oversight requirements as well. And sometimes we can identify bias also. So these are the high level things. Um, and I will come here directly, like how we can achieve that part. So if you just focus on the blue boxes and the blue lines here, so this is the HC standardization closed loop for automation. So on the top left, you see the environment where the data is collected. The data is sent to the machine learning models where some predictions or some classifications will be the outcome, and that outcome is provided to the machine reasoning components, which will use the knowledge base and will provide some recommendations actually to the orchestration control action at the top right box. And that orchestration or control unit will actually perform the actuation on the environment. So this is like a control loop for autonomous system to enable automation. And if there is a human in the loop, it can be a decision maker or it can be a stakeholder, which you see at the top in the green. Then this orchestration agent will provide its proposal. Or if you see the outer blue boxes and the outer blue arrows there, they present the closed loop for automation for the telecom domain. And this blue box is presented or inspired by the HC standardization part. So we collect the data from the environment, we apply machine learning models at top of it to which gives us results which can be predictions or classifications. We input all those things to our machine reasoning components here at the right, and then the machine reasoning components will basically use the knowledge base and the context and provide some recommendations to the orchestration control action component. If there is no human, these actions can be performed directly at the environment. And if there is a human in the loop, like the stakeholder or decision makers, the proposals or recommendations are provided to them, and then the human chooses which action or proposal or action or recommendation to be actuated in the system. This is like an automation control loop to incorporate explainability by design and to have like it an integral part of it. Explainability will be needed at different levels. The first is the explainability of the data, which is like explainability of the data methods here, which will provide us some type of explanation, which can be shown to the different types of users here. Then explainability is also applied at machine learning models, which usually provide us the feature explanations or give us like important parameters who contributed to a certain prediction or classification there. Then there is also different methods for to apply it on machine reasoning components, which is called like explainability for machine reasoning. The output can be like causal relationships and that parts. So these like methods, when applied on their respective AI techniques, provides us explanations and they help us to validate the correctness, but they also input AI to work better. For example, when we input feature analysis part from the explainability of machine learning and we input it to the reasoning component can make then better decisions using this also as an input to the part. And other part, which is like really a future direction, is to machine explainability, how one machine can explain its output to the other machine and the other machine understands and incorporates it into the system. Yeah, we move. Next, I will present a couple of use cases where we have applied different AI methods. So here, this is a use case of 5G network slice assurance. So each network slice has a certain quality of service requirements, like certain throughput or certain latency or availability, and these quality of service requirements must be met throughout the life cycle of the slice, and these are agreed with the customer in the service level agreement or the SLA. So if this SLA is violated at a certain time, then the penalty has to be paid. That since you don't meet the quality of service requirements, some penalty applies there. It's a loss. So instead of just waiting that a violation occurs and then you solve it in a reactive manner, it's always useful to solve it in a proactive manner. Like we can use simple machine learning methods to predict an SLA violation. Like here you can see that in this graph we identified that a violation could occur in future. This is like a potential violation, and we can identify then the root cause of this violation, what is causing this violation to occur in the network, and explainable AI methods can help us. And then the output of this violation and its causes can be sent to a recommendation solution, which can then propose us some recommendations part which we can apply. And in this way, it will be a closed loop to enable automation and to avoid this violation in proactive manner. So after like applying machine learning methods, we applied explainable AI for machine learning, and we identified that what are like the causes of these problems, and we checked it with different methods just to make sure that yes, the explainability methods are itself correct and providing us the correct solutions. So these feature analysis or output of the explainability was then provided to the reasoning component. So here you see that the diagnosis component, machine learning performed prediction, diagnosis component using the explainable AI identified where the problem is. So it identified that the problem is at this particular router where this port will become congested, and due to that the latency requirement could not be met. The data packets will be rejected here or take a long time when the port will be congested. So one solution could be to change the router, or another solution could be to change to another port. So in this case, it was identified that another port can be used, but then this application will need to be moved to another data center here. So you see, by using different AI components and incorporating explainable AI there by design, we can not just meet the regulatory needs, or we cannot just validate the correctness of the AI algorithm, but we can also enable the automation of the whole system. I provided you like some example and showed you like some methods here that we have used for explainability for machine learning. Another AI technique is reinforcement learning, where the agent learns from the environment and using the reward function, and then it like optimizes its policy. And we see that in reinforcement learning as well, like all these components are the black box models. Here we are identifying the need to make all these black boxes a bit more transparent or explainable. So different techniques are applied there, and these are all state-of-the-art methods. Autonomous policy explanation explains the action and the state, the reward decomposition, linear model tree, constructive explanations. All these methods not just work at different levels of the model, but they also provide different levels of explainability as well. Reward decomposition, for example, provides detailed analysis, while autonomous policy explanation explains the policy which is learned by the agent in a very easy or natural language form. So this method is very good when we are explaining it to the external customers, or where the customer does not need to understand the detailed working of the systems, but just needs an explanation uh, to see and validate and ensure the correctness of the system and investigate the system as well for certain situations, while the other methods can provide us the detailed explanations, and those detailed explanations can be used by internal developers or model monitors, etc. We have also developed our own methods in-house, and you can go and check the details in the paper. But yes, this particular method actually connects the input features or the input parameters of the system with the reward. And I will show you the example here. This is another use case which we call like remote electric tilt use case. So the base stations have the antennas. So if we tilt down the antenna, its coverage decreases. So less number of users are covered, but the quality of the cellular network increases. And if the tilt up action is performed, the quality decreases, but the coverage or the number of users connected to that really increases. So for and this is like very dynamic environment. We change this tilting of the antennas based on the external environment, how many users are there, where the users are, which type of network quality do the users basically need. In addition to that, like if both antennas are tilting up and increasing the coverage, then there are high chances that at some point they will interfere in the frequency. So the interference will be increased. So it is a very complex, multi-agent, dynamic environment. We are applying reinforcement learning to automatically control the tilt, and now our this solution is implemented in Verizon's I think 27,000 base stations in US. Uh, so when it comes to the explanation part here, then the autonomous policy explanations provide us the explanations in natural language form. It can be the when questions, it can be the what question, it can also be what if question, what if you do a certain situation, what if the number of users exceed, and all these questions. And these explanations are like very good for the external customers. On the other hand, we also need to validate the correctness and test the system internally that it is behaving well all the time. And for that, like we use and apply our own method, the BRL method, where it can provide us the contrastive explanation of why action one, like up tilt, is chosen rather than no tilting at all. And you see the output is very complicated. It is not for the external customer at all. It is used by the internal users. Okay, so I think I covered like many of my points where explainability can be used and how we are applying different methods in telecom networks. I will like stop my presentation at this slide. Trustworthy AI is needed for the society. Our regulations are moving towards there. And as the previous speaker also said, like it is what type of society do we need? Do we let AI do all the wild things, or do we need the regulatory bodies? So we need the regulations will be there. Standardization bodies, they are moving forward. And to create a reliable society, we all need to work together in the ecosystem. Academia needs to do a lot of research to develop the new methods so that we can incorporate these methods into the industry, into the businesses, and into our uh, like society overall. Thank you so much. Are
Thank
there
you
any questions?
Yeah, thank you so much, Rafia. It was really, really an interesting presentation, and it's really appreciated to see how you have a practical example of how this can be into an industrial use case. We have a couple of questions. One of them coming from Michelle, and I think it's really interesting. Is do you consider tools that analyze the quality of the explanations?
We don't have really the tools for that, but we have some techniques for the explainable AI quantification part. Like I just showed that the correctness. We are just so far like the example was only the comparison of different methods to validate that yes, if all the methods are giving us similar results, we can they. But there are techniques we are working on as well, and I can share our recent work also. But this is a very recent technique, and it is an open question. We like research, even academic research, don't have all the answers on validating the explainability itself. But it's a lot of need is there to work on
Yeah,
that.
yeah. I
Yes.
imagine because indeed, I think we all have the feeling that everything is going very fast. And indeed, the second question that I think is also related in that area is coming from Robert Ball, is how can we better categorize types of artificial intelligence to encourage discussion from a mutually understood place? Because I think it's we have AI from different points of view, different let's say applications and also domains, and also explainability should go in the same place. So how do you see that?
Uh, Once more, it was a long one.
Yeah.
Or maybe I go to the chat and then.
Okay. No, if not, we can let it, you think, for having discussion in the round table, because I think this is also related with the ethicals and also the society we want to have and where we want to go at the end of the day. So thank you so much, Rafia, for your
Thank you. And I am sharing the link in the question and answers for the matrix and properties.
Okay, appreciated. Thank you.
Thank you.